So when atoms bond into molecules, their shape is governed mainly by the electrons of the atoms. This is hydrochloric acid, HCl. Here's the hydrogen atom, and here's the chlorine. And of course, there are electrons that were not shown in this model, and those electrons are all negative. And similar charges repel against each other. So they want to have these electrons on this end as far away from the ones on this end as possible, which means these two atoms become 180 degrees apart. But if you increase the number of atoms, things get a little more complicated. This is sulfur dioxide, sulfur in the middle and two oxygens. You'll notice that one of those oxygens is double bonded, and this is a lone pair of electrons, a non-bonding pair of electrons. So you would think this would normally be a linear or 180 degree molecule like HCl was, but because of this lone pair, they take up more room than the rest of the electrons, and it kind of forces the molecule to bend downwards. So you can see the angle that it creates. The next molecule is water, H2O, two hydrogens and oxygen in the middle. And again, you might think this would be a linear molecule with the two hydrogens at each end, but there are two lone pairs of electrons here. And that's important. The previous molecule only had one lone pair, and it caused the molecule to bend downwards. Well, now we have two lone pair, which means this angle is actually sharper than it was in the previous molecule. Now, if you increase the number of atoms again, this is ammonia, or NH3. Ammonia is in the middle with three hydrogens. Again, all those electrons from these hydrogens, they're going to try to be as far apart from each other as possible. And you would think perhaps that they would be lined up in the same plane, but once again, there's a lone pair of non-bonding electrons on top that forces the hydrogens to go downwards. And we call this a trigonal pyramidal molecule. Now, if we keep increasing things, this is sulfur trioxide. And you notice they're all double bonded. But there are no lone pairs here. So these exist on a single plane. You can see they're all on the same plane. They're not pushed downwards by any lone pairs of electrons. This is trigonal planar. Methane, natural gas, CH4, carbon is in the middle with hydrogens around it. And again, there are electrons at each of these positions, so they're going to try to be as far apart from each other as possible. With this number of atoms, that means we have a tetrahedral arrangement, and the angles are 109.5 degrees. If you increase the number of atoms once again, you get to PCl5, phosphorous pentachloride, and this is trigonal bipyramidal. Notice that the three in the middle are on the same plane. And then there's one coming up and one going down, and now each of the electrons here, all of them, they're as far apart as they can be from each other. Trigonal bipyramidal.